Hello students, today we are going to see one more important topic from the subject computer graphics. Our today's topic is polygon filling algorithms. I am Professor Umesh K. Gaikwad and today I am going to solve the issue of polygon filling. Before starting the lecture, we will discuss outline related with the session. First of all, we will see polygon and its type. Then we will see first polygon filling algorithm, that is boundary fill algorithm. Then second algorithm, which is flood fill algorithm. And after that, we will learn approaches for traversing purpose. Whenever we want to fill polygon, then one by one we have to visit each and every pixel which is present inside the polygon. It is called as a traversing. And for that traversing purpose, two approaches are there. First one is 4 connected region approach and second one is 8 connected region approach. Today we are going to see both approaches. So we'll start with the lecture. So first of all, we will see what is a polygon. As mentioned in the presentation, it is an ordered list of vertices which forms closed loop of line segment. So there is no open, section in between that area. So particular area will get closed by using number of line segment. There are two types of polygon, convex polygon and concave polygon. Now in the convex polygon, if you are going to take any 2 points which are already present inside the polygon, and if you draw a line which joins these 2 points, then what we will get? Observe that thing, and if all points which are present on that line which is joining both points, if all points are inside the polygon, then it is a convex kind of polygon, which is the simplest form of a polygon. Very easy. Second type of polygon is concave polygon. In the concave polygon, if you take 2 points, same like a previous case, and if you are going to join those 2 points, and obviously these 2 points must be from inner part of the polygon. If you are going to join these 2 points, then whatever result is there, observe that result. In some cases might possible that all points of that line lies inside the polygon. For example, here there is a line which is connecting 2 points C and D, and in this case all points of that line are inside the polygon. But in another case, in case of line segment AB, the color which is shaded in the shaded with the red color, the part which is shaded with the red color, that part is outside the polygon. So if there is a case in which few points of the line which is connecting 2 points which are already present in the polygon, if few points of that line lies outside the polygon, then that kind of polygon, it is called as a concave polygon. Now after learning types of polygon, we have already studied there are two types of the polygon, concave polygon and convex polygon. We will see polygon filling algorithms. Polygon filling means what? Polygon filling is the process of coloring region or area which is present inside the polygon. How can we define these regions, or how can we define that area? By using collection of pixels, we can define that area. It means indirectly we can say that polygon filling means nothing but the pixel coloring which are present, or which are the pixel coloring which are representing area present inside the polygon. Now there are two categories in polygon filling. First category is seed fill color filling algorithm. In seed fill color fill algorithm, main concept is that we have to select a point which is already there inside the polygon, and that point is called as a seed point. In this first case, our algorithm execution will get started from that seed point. Second thing is that under the seed fill color filling algorithm, two types are there, boundary fill and flood fill algorithm. Today we are going to see these two types. Another category is scan line color filling algorithm. Scanline color filling algorithm is geometrical level color filling algorithm. So both approaches or both categories are using different level of conceptual base. Now we will start with the boundary fill algorithm. In the boundary fill algorithm, concept is very simple. But before starting the algorithm, we have to assume few things. While using boundary fill algorithm, we assume that whatever boundary is there for a particular area or for particular polygon, we are going to use color of that boundary to fill inner part of the polygon. So boundary color is very important. We are assuming that boundary color and inner color, both colors are different, and we will fill inner area by using boundary color of the polygon. In this algorithm, we will start from the seed point. Seed point is the point which is present inside the polygon. It can be, we can select any random point as a seed point, and we have to start our algorithm from that point. Whenever we are going to start our algorithm, we will see whether seed point is having same color like boundary or not. If it is not having same color like boundary color, it means that we have to fill that pixel, which is seed pixel. After filling that pixel, we will visit to next pixel, which is a neighbor of seed point. Likewise, we will continue our algorithm till the end of coloring. Whenever our algorithm will get boundary color at the end, then we will get idea that yes, or system will get idea that yes, now algorithm or our application has filled all pixels from the inner side, and now algorithm or application filling or color filling is already completed, and now we reach to the boundary, so we have to stop the algorithm, and likewise algorithm will stop the execution. It is the concept of boundary fill algorithm. This is a pseudocode for boundary fill algorithm. If you are observing, main thing about the boundary fill algorithm is recursion. You can observe recursion is there. Inside the boundary fill algorithm, we are again calling boundary fill. Okay, so boundary fill is a method, and inside that method we are again calling that method 4 times. Why 4 times? We are considering that seed pixel is having 4 neighbors or 4 direction: left, right, top and bottom, and for every direction we are again calling boundary fill algorithm. So basic assumption is that every pixel is having neighbor pixel in 4 direction, and because of that we are calling this algorithm recursively 4 times. And condition is that whenever we will get the pixel, we have to compare its color with boundary color. If that pixel and boundary color is same, then that code will not get executed. If that pixel is already having the new color which we want to use for filling purpose, then that pixel will not get colored, because already we have colored that pixel. That is the thing. So we have to follow 2 conditions: whether a pixel is having boundary color or not, and whether pixel is already colored or not. And if both conditions are false, then we will start coloring of that pixel. We will color that pixel by using our pre-decided color, and as I said, recursively we will call boundary fill function again 4 times for top, bottom, left and right direction. So what are the different parameters which we have to pass to this method or to this function? We have to pass location of that pixel. We have to pass the color which we want to use for filling purpose, that is a new color, and we have to pass boundary color which is there with that shape. So this is a boundary fill algorithm. After that we will see next algorithm. But why another algorithm is necessary for filling purpose? First thing is that boundary fill algorithm is a good option for filling that shape which is enclosed by the boundary which is having same color. Means all the segments which are a part of boundary are having same color. But if different segments are having different colors, then what should we do? Boundary fill algorithm will not work in that case. If area is not defined within a single color boundary, then that is a problematic situation and which cannot be handled by boundary fill algorithm. Basic assumption for boundary fill algorithm is that all the segments which are part of boundary having same color, means boundary color is a single color. But if lot of colors are there for different edges of a boundary, then we have to use flood fill algorithm. 80% part of flood fill and boundary fill algorithm is same. Then what is the difference? Difference is present where we are going to put the conditions. Same like seed fill, boundary fill algorithm, we will start from seed point. Before that we will decide the color which we want to use for filling purpose. After that, what we will do, we will start the execution of algorithm by selecting one seed point which is the inner pixel of that polygon. After selecting that seed point, now what we will do, instead of checking color of that pixel with the boundary color, we will adopt different approach. Now here we will check whether that particular pixel is already having our new color or not. So two colors are there, old color of that pixel before the coloring, and after the coloring that pixel will get new color. So what we have to do, or what algorithm should do, algorithm will check whether that particular pixel is having new color or old color. Old color means what? Still coloring is remaining. New color means what? It is already colored. Based on this condition, we will take the decision. This is the algorithm for flood fill. If you are observing, condition is very easy. If pixel is having old color, then we have to color it. If that condition is true, that pixel is having old color, it means that we have to use new color, which is a fill color, for coloring the pixel. And if pixel is not having old color, if pixel is having new color, then that particular condition which is present inside the if loop, it will get failed. It will return false. And in that case, this particular part will not get executed. So to execute this particular part, it is mandatory that pixel must have old color, and then we can fill that pixel with the new color, and that new color is a fill color. Again, parameters are same. We have to pass location of that pixel which we want to fill. We have to pass new color, which is a fill color, and we have to pass old color, which is there with the all points of the inner part of the polygon. One more similarity is that here also you will observe, or you can observe, recursion is present. So recursively we are calling flood fill function 4 times inside flood fill. So this is the outer flood fill call, flood fill definition, and inside that we are calling flood fill 4 times. I already mentioned that why we are calling flood fill 4 times, because whenever we want to execute or whenever we want to traverse, then there are 4 options as per this algorithm. We can traverse in top direction from that pixel, we can select left side pixel, we can select right side pixel, or we can select bottom side pixel. So because of that we are calling it recursively 4 times. Now after this we will see how to visit neighbor pixels. As per the algorithm, whenever we are going to finish the process of coloring a particular pixel, then after that we have to select another pixel for coloring purpose. That pixel will be neighboring pixel. But how to visit that pixel, how to select that particular pixel, it comes under the traversing strategy, and for that purpose 2 options are there. First option is 4 connected region traversing, and second is 8 connected region traversing. In first option, we assume that from the current pixel there are 4 directions where we can traverse: top, bottom, right and left. So 4 options are available for selection purpose. We can select any of the pixel for coloring purpose. While in 8 connected region, 8 options are available. In those 8 options, 4 options are same like a previous section or previous type, that is top, bottom, right and left. Along with it, 4 more options are there for traversing purpose. Those options are in the diagonal position. Now we will see 4 connected approach. In the 4 connected approach, let's assume this is your polygon and boundary of the polygon is in black color. So whatever black color pixels are there, every circle is going to represent one pixel and black color pixels are representing the boundary, and we have to fill color to the inner part. Now we will select this particular pixel which is there, which is highlighted by using red arrow for the filling purpose, and it is the first seed point. Initially we are going to select it. Now as per the 4 connected strategy, in the 4 directions options are available, but at bottom side whatever pixel is there from the current position, that pixel is already having boundary color. So we are not going to select that pixel. So 3 options are remaining, pixel number 1, 2, 3. So from here we will select pixel number 3. Now at pixel number 3, after coloring that pixel, now we will check whether that pixel is having boundary color or not. That pixel is not having boundary color, so obviously we can fill that color or pixel with the new color. After that, again we will search for new options. From here, as per the 4 connected strategy, 4 options are there, out of which right and bottom option is having boundary color, so we are going to omit those options. Now 2 options are remaining. Those 2 options are 4 and left side pixel, but left side pixel is already having color. So from that left side pixel we will get one more option, that is option 2 and option 1. So likewise, if you are going to traverse in top direction, then option is 4. If you are going to traverse in left direction, then that pixel is already having color, and from that pixel if you are going to continue that traversing, then we will get 2 more options, that is pixel 1 and 2. Likewise we will get option 4, 2, 1 for traversing purpose. Now here after selecting option number 4, from that 4 again we are having options for traversing purpose, and those options are 2 and 1. Likewise we will continue the process, and at last only one option is remaining, that is option number 1. But from that 1 it is not possible to traverse in another section. From 1 it is not possible to traverse in this particular section. So some pixels are still remaining as it is. So though this particular part gets filled because of boundary fill, but this upper part will remain as it is. This is a limitation of this boundary fill. In boundary fill it might possible that some pixel will remain as it is, those pixels will not get color. So if polygon having such kind of shape, then it might possible that in some cases some of the pixel will remain as it is without the color. So this is one of the case. To solve that case, we are having 8 connected option. In 8 connected option, we are having assumption that every pixel is having 8 neighbors and we can traverse in or we can travel in any direction. Here we will select seed point shown by the red arrow. From that seed point, here we are having 8 options, out of which already 3 options are having black color, that is the boundary color. So remaining options are 5, 4, 3, 2 and 1. After this, we will traverse towards the pixel 5, and from there we will get option 6, 4, 3, 2, 1. Likewise, we will keep our traversing in the continue phase, and every time we will get less or more number of options, and slowly we will move towards the end. So here, after many iterations, if you are observing, it will take many iterations, and after many iterations, slowly if you are observing, number of pixels having new colors are increasing in the number, and number of pixels having old color are decreasing in the number, and at last only one option will remain. That option is 1. And at last we will fill color to 1, and if you are observing with a connected approach, all pixels guaranteed, it is guaranteed that all pixels will get color. So it is sufficient, or this algorithm is one of the good option for removing limitations of another algorithm, that is boundary fill algorithm. Sorry, that is a 4 connected approach. So whenever there is a complex polygon, then it is better to select 8 connected option. But if polygon is having very simple shape, then 4 connected option is also sufficient. 4 connected option is faster as compared to 8 connected option, because in 8 connected options we are having lot of directions for traversing purpose, but otherwise some limitations are there with 4. So if you are having much more availability of time, then 8 connected is good option. At last we will get picture like this with the 8 connected approach. Now at the end part we will compare flood fill with the boundary fill. If you are going to compare flood fill with the boundary fill, then few main things are there. In flood fill, comparison is based on one thing, that is whether current selected pixel is having old color or new color. While in the boundary fill, filling decision is based on 2 conditions. First condition is that whether current pixel is having boundary color or not, and whether current pixel is having new color or old color. Boundary fill algorithm is less time consuming, it is faster than flood fill algorithm. Also memory requirement of boundary fill is less as compared to flood fill. So flood fill has some advantages as well as limitations as compared to boundary fill. In the summarization, we can claim that we can use any algorithm as per our need, but as per the algorithm selection we have to mold our condition. 80% part of both algorithms is same, only difference is there that whenever we are going to decide, or whenever there is a time to decide whether we have to fill color or not, we have to check few conditions, and in both algorithms those conditions are different. Both algorithms are having own similarity, both algorithms are also having some similarities. As I said, 80% part is same, and one of the main component of that 80% part is recursion. Base for both algorithms is recursion. As I said, in the definition of boundary fill or flood fill, recursively we have to call same function 4 times if it is a 4 connected approach, and if it is 8 connected approach, then recursively we have to call it 8 times. Because in 4 connected we are going to consider 4 direction for traversing, and in 8 connected we are going to consider 8 directions for traversing purpose. We have also seen 4 connected and 8 connected approaches. As per the need, as per the demand, as per the situation, we can select 4 connected, but we know that there is a limitation with 4 connected. In case of some of the polygon, it might possible that some of the pixels will remain as it is, will remain without the color. So we have to take care of that. In that case, better option is use of 8 connected pixel. So 4 connected region and 8 connected region, these are 2 options available for selecting next pixel after the coloring. Okay, and these approaches are for 2 algorithms, that is boundary fill and flood fill. One more point I want to summarize, that is a seed pixel. Seed pixel, we have studied that seed pixel is that pixel from where we can start the execution, which is the initial point for the execution, and that point must be from inner part of the polygon, and we have to start from that seed pixel. At first part of the lecture we also studied that there are 2 types of the polygon, concave polygon and convex polygon. If you are going to take 2 points and if you are going to draw a line between these 2 points, if all points present on that line, if those points lies inside the polygon completely, then that is a convex. If some of the points lies outside the polygon, then that type is concave polygon. Okay, and in the first glance, concave polygon has little bit complex structure as well as compared to the convex polygon. So this is about polygon filling algorithm from seed fill category, and in the next session we will see scan fill algorithm. Scan fill algorithm has totally different base of the concept. Scan fill algorithm is a geometric level algorithm in which the main component is line drawing algorithm. We have to identify points and we have to draw a line which will join two points which are present on the edges of the polygon. So that has different conceptual base. These two algorithms are having different conceptual base. In next session or next lecture we will see scan fill line drawing algorithm. Thank you.